Hello, computer science geeks. This is Mr. Stride. We are going to do a summary of Unit 8 today, and we're also going to apply some other learning. We're going to learn implicit parameters. We're going to learn implicit this. We're going to learn class invariants, and we're going to cover a lot of different stuff today. If anything you don't understand here today, I know I'm not going to go into too much detail on all the stuff that we've already covered, but it should give a pretty good summary of everything we've already done. So we're going to start off with this code that I have here. Unit 8 summary has a main method. I'm going to create two fractions. This one I'm calling the constructor that has no arguments, and this one I'm calling a constructor that has two arguments. Then what I'm going to do is I'm going to call this setter. This is a setter on fraction 1. We also call them mutators. I'm going to set the numerator to 20, and then I'm going to print it out using our fancy schmancy printf. So I get my format string right here, which says I'm going to take 3 arguments after this formatted string. I'm going to take the f1, f2, and the answer, f1, f2, and then I'm going to add the two fractions together. And then just to let you know that when I add fractions together, this is not a mutator. This is just a function that adds these two fractions together. It does not change f1, so I print f1 out again to see what we can do, or to see how it worked. Let's see if it works. All right, first thing, let's run it. Okay, I created a fraction. What do you think I created two? Well, we'll find out in just a second. We're going to look at the code in more detail. Then I set the numerator to 20. Go in here. Notice that I never did set the denominator 1. It just magically got there. Then I take the 3 halves, the numerator and the denominator here. I add them together, and I sure hope it did the math correctly because I haven't checked my work here. That looks about right. And then at the end, I print out the same fraction here. F1 has been unchanged. Okay, so let's take a look at the fraction class to see what's going on here. What I'm going to do is I'm going to set a breakpoint inside this method right here. I'm going to go back to Unit 8 summary, and then I'm going to debug this puppy, and we're going to see what happens. All right, I set my breakpoint here. What you'll see is that in my call stack, I haven't covered call stacks yet. I started off in main, then I went into my fraction right down here because you see I'm creating a fraction with 0 arguments. So it goes into my constructor right here. Oh, sorry. Yeah, right here that has no arguments in it. And then I come back up here. How did all that work? That seems like pretty crazy stuff, right? Well, when I came here, this is my parameters constructor. I'm going to create something. What I normally wanted to do when I have no arguments is I want to set the numerator 0 and I want to set the denominator to 1. So I use the this constructor and I call up into this constructor here. Why do I do that? Because I get some extra functionality when I call this constructor up here at the top one. Because right up here at the top, you see that I check to see if my denominator is 0. If it is 0, I'm going to throw an illegal argument exception. You are not allowed to create a fraction where the denominator is 0. Just can't do it. You'll see why? Because I am stating that a class invariant, there's a class invariant for fraction is that the denominator must be greater than 0. Here, I just make sure that it is not 0. I should probably change that to make sure it's greater than 0, but we do that later on, okay? Actually, well, I'll do that later on. I'll show you. We fix that later on. So this is how I call, this is the this constructor. I'm calling a different constructor, and then I can step through the code, and I set the numerator and denominator. This numerator is this numerator. This numerator is the instance field up here. Every fraction has a numerator, every fraction has a denominator. They have their own specific ones. So I have to use this as I go through. So when I return out of there, I come back here. Now when I step in here, where am I going to go? Am I going to go to constructor or what? I come into the constructor that has 2 parameters. Again, I step through and I just set my stuff in there. Now, here's an interesting thing. I'm going to set my numerator to 20. I go into this setter. This is a setter. It's also a mutator because a mutator is any method that changes the state of the object. What is the state? The state are the instance fields. So if I'm going to change numerator or denominator, then it is a mutator. So all I do is I set this num is equal to numerator there. So far, so good. When I go to add the fraction, when I call this method, the first thing it's going to do is it's going to go into this method, add, on the class f1, or the fraction. So I've called add. There's only one argument up here. That was the f2. You can see right here I have one argument in this method. When I called it, that argument gets set to other. So this is the other fraction. When I add two fractions together, I got to get a common denominator. I'm going to do cross multiplying to get my numerator and the other numerator. Then I'm going to create a brand new fraction. Okay. When I create a brand new fraction, I'm going to return that fraction. I am not changing this object at all. Okay. I'm not changing this object, so this is not a mutator method. The fraction remains unchanged. I step through and I'm going to add my numerator and the other numerator together. I'm going to go with the new common denominator and I'm going to create a new fraction. If I step into this, I come up into my constructor object in here where I check to see if the denominator is 0. If it is, I throw an illegal argument exception and I come on through and I create my new fraction. I set that new fraction into answer and then I'm going to call normalize. Normalize does a few things for me. Okay? Normalize is a mutator. It's going to change the fraction object. It's going to see if the denominator is less than 0. It's not allowed to be less than 0. That is my invariant. So I need to multiply both the numerator and denominator by -1 so that my numerator becomes positive. After I do that, oh, well, I didn't have to actually do it because it was positive already. Then I'm going to reduce this fraction, okay? Right here I have this. This is not necessary. I could be using just reduce. When I have just reduce, this is implied, okay? So this is implied if I don't put it. I explicitly put it here, so we know that we are reducing this fraction, okay? This fraction right here has a numerator and denominator. This fraction has a numerator of 43 and denominator of 2. I have no arguments in here, so you can't see anything else. When I go to reduce, we're going to get even more fancy. I'm in my reduce method. No arguments. I'm in this object because I'm not in a static method. I'm going to ask my helper class for the method getGCD. It's going to get the GCD for what? For this fraction. This is a pointer to the fraction. So when I step into that method, I'm going to be in the class myHelper. I'm in myHelper. It is a static method, which is why I had myHelper dot. MyHelper dot says go into this class, use the static method. Pass in the parameter this, which is a fraction, because I'm in the fraction class. This is a fraction. I go into my fraction, or go into my helper class. It takes a fraction. F is 43 and 2. That was the same as this object that we had earlier. I'm going to use my getters to get the numerator. I'm going to use my getters to get the denominator. And then I'm going to call the other static method, getGCD, up here, which uses Euclid's method to return the GCD. I'm not going to step into that method. We're just going to assume that it works. Now I have my GCD. I'm using the this again. Do I need to use this here? I do not, because there is no other numerator or num variable in this scope, so there is no conflict. If I left this out, this would be implied. It would be implied, but I use it here explicitly just to be clear that I'm changing this object, so this is a mutator object. I'm changing by the GCD and the numerator, and I'm reducing it. After I reduce the fraction, I'm returning this. Oh my gosh, what is this? This is a reference to myself. It is the object. It is a fraction. So I'm returning a fraction. Not only did I change myself because I'm a mutator, I am then returning myself. I return myself, so that way, when I return off of normalize, it is the answer. I can just return the answer here. So I return myself from normalize, and then I return that again from add. Whew. A lot of stuff going on there. When I return that, then I came all the way through, and I got a fraction object here, which I print. This fraction object is not F1, it is not F2, it was a brand new fraction object created that was added together. So when I print, right, I printed this at the top line, and then this was the next line there. Can I call F1 reduce? Let's say that I wanted to call F1 reduce. Is that possible? The answer is no, because reduce is private. If I go back into this class here, I finish running. If I attempt to pull this out and then I compile, the compiler gives me an error. It says, error, reduce method in class fraction cannot be applied to, it's a long message, to given types, okay? Because it doesn't know that reduce even exists, because reduce is a private method. So I have to take that out in order for it to compile. So we covered a lot of different things in here. Let's go back up to a fraction. Let's work top down. It's an invariant where my denominator is greater than 0. In order to make this true here, what I should probably do is I should say if this denominator is less than 0, then I need to multiply this num by -1 and this denominator by -1. Now it's truly going to be an invariant here because I can't set a denominator that's going to be negative, okay? That is my invariant. Invariant means it doesn't change. It's always going to be true. When I look at this fraction, it's always going to be true that my denominator is greater than 0. I have a parameterless constructor. There is no default constructor in this class because I am providing not just one constructor, I am providing 2 constructors. My constructors are overloaded. This one takes 2 parameters, this one takes 0. From this one I call the this constructor, so that way I can borrow all the cool functionality up here that throws an illegal argument exception if it is equal to 0 and also maintains my invariant. I can add 2 fractions together inside of this class, of this instance, using this instance method. It will add this fraction with the other fraction. If I wanted to, I could use, and in this case, this is implied. What do you mean this is implied? All right, this method here is virtually identical to the one above to it, except I'm providing the other fraction here and adding those together. In this case, I can just simply call F1 and return the fraction that way, and then of course the easiest, I am normalizing, which I should probably, you know, I don't need to normalize down here because I already have it. I cannot call reduce without explicitly saying the fraction we are trying to reduce. So this would not work. Okay, if I try to attempt to compile that code, it says non-static method reduce cannot be referenced from a static context. I'm in a static method. This is an instance method. There's no static here. It needs to know what object we are working on. Well, we're working on this object, right? Can't I just do this? Let me try that. Let me try this. Okay, here again, it gives me the error. It says non-static variable this cannot be referenced from a static context. It doesn't know what this is, okay? When I'm in a static method, I'm in the blueprint, okay? I have no idea which fraction I am talking about. Both fractions were passed in. By golly, if you want to use one of those fractions, just use one of those fractions. So I can't say this reduce. I can't say reduce. Reduce and this reduce are identical. If I just have reduce, this is implied. But this doesn't exist inside of the static method. So if I want to reduce, I have to call f1 dot reduce. Of course, none of this is really necessary because when I normalize my fraction, wherever that is, when I normalize, I also reduce. So it's really unnecessary to do it in this case because everything is taken care of for me up here. I was doing it just to prove my point. So I would do answer f1 can reduce. Can I do that? Can I do f1 reduce? Well, wait a minute. When I add, I'm not changing f1, so that's not at all what I'm going to do. I want to do answer reduce. Will this work? Can I do answer equals answer reduce? I can't because reduce doesn't return a type. It doesn't return a type. Wouldn't it be cool if I could just do this, answer dot reduce, just return it? That would be cool, right? But I'm going to compile again just to illustrate. That doesn't work. If I want that to work, I'd have to go to my reduce method and say it returns a fraction. And then what will I return here? Ret run. You know what I return? This. Okay? I return this. I operated on this. If I return this, now I compile. It compiles just fine without error. That way I can do return, answer, reduce if I wanted to. Of course, I already did reduce in my f1 up here, or in my add, so that was not necessary. I love the toString method. When I have my toString method, that is exactly why I can just print f1 directly. When I do f1, this is identical to doing this. Okay? The toString is implied. That returns me a string. Those are identical. I can leave that there. I compile. Everything works just fine. So that's a very handy method. We already talked about reduce. Got my static method on my helper class, and I pass in a reference to this object, which is a fraction. Here is my explicit this, or reduce, done again. Let's look at this. I'm repeating this because it's so cool. I have a reduce, no static. It's an instance method. This method and this method, well, they're not identical right now. I have to go like this. Fraction. What would I return? They are identical. There's no parameter here. This is implied. If I wanted to, I could explicitly put this. I have to put a capital T because the lowercase t, this, is a keyword, and I can't do that. If I put capital this, I can do my same method there. Right here, instead of lowercase this, I would do uppercase this. Here, this is implied. Here, this is explicit. Because I'm in a static method, I can pass it in. Could have made it an implicit method, but that would be really, or an instance method, that would be really weird. I'm going to leave it as static. This is explicit. This is implied. I changed the numerator and denominator. Wait a minute. Isn't the numerator and denominator, isn't that private? It is. It's private. How can I do that? Well, it's private to all my external clients. It's accessible to anything within fraction. Because this method is inside the fraction class, I have access to the private instance fields. So I can do that. Do you guys figure out what to return here? Not this. This. That'll return it. Now these two methods are identical. Nothing new to cover there. We have our getters and accessors have the same names. All I'm doing is I'm adding a public ability to get the instance fields by having a getter. We call them accessor. It gives me access to the values or to the properties. I have my mutators, which means it allows me to set the numerator. When I set the numerator, I don't need to change a thing. I just can simply set it because any numerator value is valid. When I set the denominator, I need to make sure you do not break the rules. If it is equal to 0, I throw an illegal argument exception. That is disallowed. If you set it to less than 0, I need to multiply the numerator and denominator by -1 to maintain our invariant. Our class invariant is that the denominator is always greater than 0. Here's some funny things. I might want to, in here, as just a possible way to implement this, is to say, you know what, I'm changing this fraction. Why don't I just set this to be a new fraction? Illegal. Can't do it. You cannot say this equals anywhere in your code. That is disallowed by Java. If I were to compile that, I get a nice error message. It says, cannot assign to this. That would have been cool if I could do it in a way, but that just gets confusing to the compiler. It's not confusing to me, and I say, well, I'm creating a new fraction object. I want this to be the new fraction object, which is the numerator and denominator. Can't do it. Well, how about this? Can I just call a constructor this way? I'm just calling the constructor, construct me a new fraction with a numerator and denominator as I said it. And the answer is no, you're not allowed to do this. This constructor is only allowed to be called in the first statement of a constructor. I'm not in a constructor, and it's certainly not the first statement. It's only allowed in the first statement of a constructor. I can't do that. So we must go ahead and access the instance field, which is legal to do even though it is private because I'm inside of my class. I'm going to set it to whether it's negative or not. Doesn't matter because I'm going to fix it down here, and I know already that it is not 0. So a lot of stuff we covered in there. I talk pretty fast because I know you can hit pause anytime you want, and that pretty much sums up everything that we need to know from Chapter 8. A lot of things in there. Hope you got it.